Okay, so the goal for today is to complete our reciprocal trig function graphs. We have them all fully covered in class. The next thing I do is I cover an AP topic. It will be brief, and it will be something that will not be on the test, but we will do a mini quiz on it the day after the test next week. And I'll be very clear exactly what's expected. It should be an automatic 10 out of 10 if you just review your notes the night before. Okay? Kind of like the unit circle. If you know it, you know it. You know, it should be an easy way to boost out your bonus potential. Okay? And then the last lesson of this unit is solving real life situations by modeling with a sinusoidal function. So we'll do 3 examples. The 3 examples we're going to do are very similar to the 3 types of problems you did in grade 11. The only big difference is you use radians instead of degrees, but it's the same process. So my goal is to complete this lesson today. This may go beyond the 2:36, so please, if you have to leave, you can leave, but if you can stay, I will, whoever can stay, I will finish the unit today, even if they go a little bit after class, okay? So we're moving on to cotan x. So yesterday we successfully completed the graphs of secant and cosecant and their characteristics. So if we're going to cotan, so now we're doing all the coordinates of x over y, and the big difference here is the graph. If you're looking at the graph of cotan x, it starts with an asymptote. The asymptotes are going to occur at every multiple of pi. And then, again, quadrant 1 is still positive, but it's all reciprocal. So normally it would increase. This is going to be reciprocals. So it's going to be root 3, 1, root 3 over 3, 0, negative root 3 over 3, negative 1, negative root 3, undefined. And then repeat it. Root 3, 1, root 3 over 3, 0, negative root 3 over 3, negative 1, negative root 3, undefined. Okay? And just to refresh your memories, the numbers in this table are going to show up are aligned with what showed up when we did the tan graph last week. Okay? Root 3 over 3 is the 0.577, and the root 3 is the 1.732. So the just higher than half and the 1 3/4, those were like the patterns if you recall. We're going to use the same scale for the horizontal. So we've got every 3 squares pi over 2. Okay. And we'll stick with our 1, 2, 3 scale. Every 2 squares is 1. So I'll give you a couple seconds to get caught up to me here. Paula, you have this? If not, Thursday, please. Okay. Good to go, guys? So again, I would always start with asymptotes. The asymptotes are at 0, pi, and 2 pi. So, okay. Okay. So again, this is where the pi over 4s suddenly become a little more useful because they're the nice numbers that are output when you find tan of pi over 4 and their multiples, you get 1s or negative 1s. So when I graph this, I'll start with the 0. So notice the zeros are at every odd pi over 2 now. Do you guys get it? Hopefully it makes sense that normally these would be where the vertical asymptotes of tangent would be. So wherever a vertical asymptote of tangent is, now there's going to be a 0. Wherever there was a 0 of tangent, now there's going to be a vertical asymptote because everything's been taken reciprocal of. Okay, so zeros have become vertical asymptotes have become zeros. And the one thing you're going to notice is if tan x looks like this, so just to refresh your memory, remember tan had this sort of a shape. The asymptotes were at pi over 2, 3 pi over 2, and it was 0 approach asymptote, and then 0 approach asymptote, approach asymptote. Remember that was basically what the graph looked like from 0 to 2 pi. What do you notice if I said what is this function always doing on its domain? It's always increasing. So what's the rule about reciprocals? It'll always be decreasing. It'll be the opposite. But wherever it's positive, it'll stay positive. Wherever it's negative, stay negative. So you guys see that this one has from between 0 and pi, it's positive asymptote negative. So always increasing. So this will be decreasing, 0 decreasing, but still positive, 0 negative. So the shape is going to be, so we've got our 1.73, so 1 3/4-ish. Our 1.5 squares is our 1. Our 1 square over is the 0.57, so slightly above 0.5. And then mirror image it below, so it's a little bit lower than 0.5. Middle is at -1. 2 squares over 1.75 approximately. So you have these 7 points. And approach asymptote. Approach asymptote. Repeat, 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 repeat. So it's this shape repeated. Okay. So 1 square over, a little bit higher than 0.5 up, 2 squares over, 1.75 up. Whoop, that's not. 1.75 up. And right in the middle would be the 1 up. And then repeat. A little bit lower than 0.5, 1.5 squares over, 1 down, 2 squares over, 1.75 down. And again. Ooh. Yes. Okay, go ahead. Okay. Okay. And then, just to add to the tediousness, here we go again. A little bit higher than 0.5 up, 1.5 squares over, 1 up, 2 squares over, 1.75 up, 1 square over, a little bit lower than 0.5 down, then 1.5 squares over, 1 down, 2 squares over, 1.75 down, and yay! One more time, here I go. 1.5 up, 1 up, 1.75 up, lower than 0.5 down, 1 down, 1.75 down. Yay! Okay. Let's get down a little better there. Alrighty. Ta-da! Cotan. Okay. So we'll finish up our characteristics. So again, let's start with the vertical asymptote general location. So how would you describe the location of all asymptotes here, generally? At every x equals, at every 0 pi, 2 pi, negative 2 pi, at every pi, every odd pi, every even pi, every pi. Every pi. We don't need to go 2k because there's actually at 1 pi, so at odd pies and even pies. So k pi. That means wherever the vertical asymptote is, that's where the domain will not exist. Okay, let's do the easy one. What's the range? What are the possible y values? Everything? Will every y value eventually be somewhere on this? True. Range. Y can be anything. How often does this repeat, guys? Every pi. And then the min-max question is irrelevant here, doesn't make sense. So, but we can still find the general location of the zeros. So if you look at where the zeros are, I see one at pi over 2. I see another one at 3 pi over 2. The next one will be at 5 pi over 2, 7 pi over 2, odd pi over 2s. Remember how we can write that? It's 2k times pi over 2. Again, if you wanted to go pi over 2 plus k pi, that would work too, right? For k element integers. All right, so there we go. We finally completed the 6 functions. So I gave you yesterday, I don't know how many of you have tried it yet, I gave like a summary sheet. Hopefully you find that useful. I accidentally made an additional class set because I forgot I'd photocopied it. So it doesn't have to be now, but later on in the week, on Thursday, if you want another copy to try and redraw it out, write it out for yourself, just let me know. I have some extra copies. I'll send a PDF. I don't know if I did already, but I'll send a PDF of it as well. So on the weekend, if you're like, I really want to fill this in again, then you can make out 10 copies and do it 10 times if you think that's going to help you, whatever way you feel you're going to know it. Because the majority of your communication mark is going to be filling in the blanks, and anything, any characteristic of any of these graphs is fair game for me to ask you. So I can ask you for zeros of cotan x. We need to be able to know that's different from the zeros of tan x, or the zeros of sine x, or the zeros of cos x. You need to be able to tell them apart. Well, again, what's the easiest thing to know is if you can make a little sketch for yourself, could you create your figure out anything without necessarily memorizing? It's your call. You can either memorize features just to have it in your brain, or you can remember the graphs and then be able to state the characteristics based on your graphs, as long as you remember the graphs correctly. Either or. All right, so officially done that lesson, so we'll move on to the bonus lesson. So the bonus lesson is inverse trig functions. So this topic is not in the regular advanced functions course, but I do want to address it at this point. It makes sense to understand that you can take inverses of any function, including trig functions. So we'll talk about what those functions look like. But this will not be on the official test. So the official test is next Monday. On Tuesday, the beginning of class, you're going to have like a 10-minute mini quiz, just knowing the content of these 6 graphs you're going to see in a moment. I'm not going to make you graph on this quiz. It's going to be a recognize the graph quiz, kind of. So you have to kind of be able to kind of label graphs and state domains and ranges. That's going to be the main focus. So let's refresh our memory. What is an inverse of a function? You've been studying inverses of functions now for 2 years. Last year, what were the main inverses you studied in grade 11? Quadratic inverse and linear inverses. Yeah, the linear ones are a little bit like, okay, ooh, exciting. Because what was the inverse of linear, guys? If don't draw, okay, this is just a refresher. You don't have to draw this, okay? If I said, here's a function, f of x equals x plus 2. Maybe I'll make it more half x plus 2. So do we all feel like we could graph that function? Yeah. I hope we're all nodding, sure, no problem. Because what would be a key point on this? You would have y-intercept at 2, and then you could repeatedly count out a slope and get more points, right? So you can go 1 up, 2 over, 1 up, 2 over, 1 down, 2 over, 1 down, 2 over, etc. Yes? Okay, so there's y equals f of x. So now, if I wanted the inverse What was the key thing if I wanted to find the inverse of this? What was the algebraic strategy for finding inverses, guys? You switched x and y. Okay, and then if you isolate y here, you would get y equals 2x minus 4. So if I plot -4, right, and then I counted a slope of 2, right, up 1 over 2, up 1 over 2, so that's hitting at 2, up 1 over 2, etc. So I end up with kind of this shape, approximately, and that would be the inverse. Inverse of linear is linear. You guys remember there was that rule that there'd be a reflection in the line y equals x. Okay, and that was easy. So we did linear. We know that the inverse of linear was linear. What was the inverse of quadratic, guys? So if you graph this, let me draw a quick inverse. So if you draw this, remember what the inverse looked like for quadratic? Sideways parabola, right? This thing happened. Well, that was bad. And if you wanted to restrict the domain of the purple to only half, then you have a square root function. Or you could start with a square root function. We talked about this back in Unit 1. If you start with a square root function, how much is the inverse? It's half a quadratic. And then you guys had in the last course, we did exponential functions. And what was the extra topic you did last year? The main extra topic in grade 11 was, and what's the relation between exponential and log? Inverses as well, right? You have I'm literally just doing logs with my grade 11s right now. So if you have an b to the x, right? Inverse, right? Y equals log x to the base b. Those are inverses of each other. So inverses play a part in all kind of aspects, and it's important to be comfortable with all these different functions. So now we're going to look at inverses of trig functions. Okay? So we're going to look at the 6 graphs. And the important thing to notice is that while trig functions are periodic, in order for the inverse to be a function, the domain of the original function must be restricted. Right? So, I don't know if you guys know about this trick. Oh, that's sadness. It's supposed to be impressive. Maybe, oh, it's with the erase. You guys remember, like, it may have. Your elementary teacher may remember that. Yeah, you try to impress your students sometimes. Okay, so before we go to the pictures, again, I just want you to understand what we're talking about here. So we all agreed there's one cycle of sine from 0, pi, 2 pi. And just to extend, I'm going to go, and here would be going backwards, negative pi, negative 2 pi. If I said you're going to take the inverse of this, do you guys get that what's going to happen is you're going to end up with, let's even just pick some points. Because the other way, remember the very first way you learned about inverses before you learned algebraic was you took coordinates and just switched x and y. So 0, 0 would stay 0, 0. So that point's going to stay the same. This would be pi over 2, 1. Okay, what would happen there? Pi over 2, 1 would become 1. Pi over 2, 1 would become 1 over and pi over 2, right? Pi over 2 is a little bit higher than 1. Okay, my scale is going to be off here. It's not going to work as well.
It's like 1.6, right?
Yeah, so I'm just going to drop below just so that you kind of get a feel for what's happening here. So 0, 0. I'd have a point over here, but then here's the next point, guys. Pi 0. What happens there?
0 pi.
0 pi. Look what happens. I'm back on the y-axis. Right? If I go backwards, negative pi over 2, negative 1 would become negative 1, negative pi.
How do you create a scale for that? That's weird.
Well, it's your scale basically is, yeah, it basically switches. Like if this is,
No, but like if you have that original one.
yeah, we usually don't graph them on the same grid.
Oh, okay.
Yeah. And so the idea here is you see that this is what's happening to our scale. You have to swap it so that the pi's are going to be on the y-axis, and the 1, negative 1 is going to be on the x. And if we do that, you guys kind of see an issue of what's going to happen.
Yeah.
Is this a function?
No.
Okay, so if you remember, we faced that problem with the quadratic. We can make the inverse a function if we restrict the domain of the original. Do you guys get that? If I just pick a little chunk of the sine graph and just take the inverse of a chunk, I just want to make sure that chunk I pick will pass the vertical line test in the inverse. Do you guys remember I was talking about if in order to pass the vertical line test in the inverse, it has to pass what test on the original?
Vertical line.
Well, it's vertical on here, horizontal line test of originals. We all agree that right now this is failing the horizontal line test. And fail, right? But if I decide to only pick a little piece of the sine graph, the smallest piece I can pick that doesn't fail the horizontal line test, I'd have to start maybe here
Yeah.
and stop here. This little wimpy kind of chunk is the max I can pick because this piece on its own passes the horizontal line test. And so if I take the inverse of just that piece and I stop at I start at pi and end at negative pi, do we see that that works?
Yeah.
Okay, so that's essentially what the inverses look like. So the one we just did is the second one in this list. So this right here, okay, is y equals sine inverse of x. Okay, so and we can't. That's the way we have to write. We literally have to leave the -1 in. There's no other way of writing it. Do you remember when you first learned exponential? The first thing you learned is you switched x and y. And then you want to isolate y. In order to isolate y, we had to we had to create a new form called log form. Well, for sine x, if I switch x and y, what's the only way you isolate y in an equation like this is you have to undo sine on both sides. You do the opposite operation of sine to both sides. What's the opposite of sine? Sine inverse. So that's literally what the equation is going to be. There's no rewriting. That's what the equation of the inverse will look like. But it's on a restricted domain so that it is a function. Okay? So, do you kind of see that the functions, just like our, sine and cosine look similar, secant and cosecant look similar, tan and cotan look similar, hopefully you recognize that same pattern occurs with the inverses because you're basically taking inverses of those same functions. So these little wavy chunks here are sine inverse and cosine inverse. How are we going to be able to tell them apart graphically? Because that's going to be one thing you're going to have to do on the quiz, is I'm going to give you one of those, and you have to pick if it's sine inverse of x or cos inverse of x. And here's what I would say is a key thing to kind of pay attention to. Those points are not on both. So you can identify which one's which by knowing which one has 0, 0 on it and which one has 1, 0 on it, because those correspond to 0, 0 and 0, 1, right? We know 0, 1 is on cosine, so 1, 0 has to be on the inverse, and 0, 0 is on sine x, so I know 0, 0 will be on the inverse. So there's one point that should be able to identify which one's which. Do you agree that the domain's the same? That's the case of all of them. The domains are the same for each pair. So each domain, like the domain of the cos inverse and sine inverse, is -1 to 1. Because remember, that's the old range. The range has become the domain. But for the range, because I have to restrict a different chunk, right? If I took cosine, right? Let's go back to here. If I drew cosine, right? You guys see that picking negative pi over 2 to pi over 2 isn't going to work, right? I need to pick a different interval. So do you see that picking from 0 to picking from 0 to pi works this time because it'll pass the horizontal line test for that piece. Make sense? So that's what changed there. Let's look at the cosecant and secant. So we know that secant and cosecant have those U shapes, repeated U's, repeated open, up, open, down, open, up, and down. So what are these going to be? Repeat like the side U's, but again, I can never have a full U because that would fail. A sideways U would fail the vertical line test. So it's half a U, half a U. Okay? And so that's what the shape looks like. And again, what's going to be the clue? What you don't see here, but maybe you want to draw in, is you guys see that in this second one there is an asymptote. It just didn't get drawn. Where do you see the asymptote happening here, guys?
Is it like 0?
Yeah. You can. Why don't you add in the label there, because that's a good, good thing to kind of keep in mind. Because does it make sense that the inverse will have horizontal asymptotes if the original had a vertical asymptote? Right? And that's how you're going to be able to tell those apart, because the asymptotes occur in different locations for cosecant and secant. Okay, the other thing that's not drawn here, but you could also add in just to be clear, is you still have asymptotic behavior, so if you want to put arrows just approaching asymptotes, you can, because that's a little more accurate. Not all textbooks will put the arrows, but it's understood that they are there, and I would expect you to draw them if I made you draw this, but I'm not going to make you draw any of these. It's a matching game, so the graphs will be there, you have to just pick the right equation.
Are they going to be like just plain?
It's literally these 6 pictures. I'm going to pick 3 of these 6, and you have to decide, it's basically one of each pair, and you have to decide which one it is and state the domain and range. That'll be 9 out of the 10 marks on your quiz, and then 1 mark is going to be a question I ask, and I'll tell you what the question is in a second. Let's finish off with tan. Can you guys see how tan is just, again, the reflection of the y equals x line of this shape, right? So this shape that heads towards negative infinity and infinity now heads horizontally towards infinity and negative infinity. So it's this shape. And again, you'll be able to tell, the big tell is, we know tan is going to have 0, 0 on it, so inverse of 0, 0, 0, 0. Cotan inverse won't, so that's how you're going to tell which one's which. If you needed to figure out a point, I don't know, another way of thinking of it is, where are, like, the endpoints here? Like, just even think of this point right here, guys. If 1 zero's on the inverse, then 0, 1 is on the original. What function has 0, 1 on it? Cosine, because it's the reciprocal of sine, or reciprocal of, okay, sorry. Secant's reciprocal of cosine. Cosine passes through 0, 1, so will secant. Again, another way of remembering. So, again, those are the 6 graphs. It's going to be a recognition game of what you're responsible for. You know what each graph looks like. Be able to match graphs to equations and or make a sketch if given one of the equations. I'm not going to make you do the sketch. It'll be the recognizing part. So if you want, you can scratch out the make a sketch. I'm not going to make you sketch it. Okay? It's not fair for me to make you sketch it when I talk to you in less than like 15 minutes. Okay? But you should be able to recognize it. And then be able to state the domain and range of each. So you guys get that I'm not a big fan that this textbook did the domain and range like this for I'd rather they have done this for these ones. I don't like mixing infinity notation with set notation. Okay, so you either do that or you can go negative infinity, infinity. Okay? And technically, just to match up over there, there'd be arrows here. Okay? The one question I will ask that will give you your 10th point on the quiz is, why do you have to restrict the domain of a trigonometric function in order to make the inverse a function, or something like that? What did I say? I think I said something to what maybe it, can't remember, guys. What did I say? I don't think I saved it. It's basically what do you need to consider in order to graph the inverse of trigonometric functions? In order for the inverse to be a function. like I worded it completely differently in period 1, but anyway. Does that make sense? Do you guys get that should be an easy mark? What do you need to consider in order to graph the inverse of trigonometric functions in order for the inverse to be a function? You have to consider that you need to restrict the domain of the original so that the inverse is a function, because I would say something to the effect of what's the common characteristic of all trigonometric functions? They starts with a P. They're periodic, means they repeat, and we know that if a function repeats, then it will fail the horizontal line test. So we need to restrict the domain of the original so that the inverse will pass the vertical. Something to that effect. Okay, 1 point. So say something about restricting the domain. Maybe draw a little picture. That would be that would be fine for me. Okay, so officially done. So your official test on Monday will not have inverse on it, but you'll have to do a little mini quiz at the very beginning of Tuesday. It's like almost unit circle in kind of scenario where it's just going to be here's 3 graphs. State what the equation is of each and state the domain and range. There's 9 points, and then 1 point for answering this question. 10 out of 10. Hope you all get 10 out of 10. So it's like, I would say what you did for limits in unit 1 is worth 1 out of 5, like it's weighted 1 out of the 5. This is weighted 1 out of the 5. And then the unit you do in January is weighted 3 out of the 5. Okay. So last lesson of this unit is word problems or modeling real life with trigonometric functions. So modeling with trigonometric functions. So again, no preamble here. I'm not reviewing what to do. We're just going to answer some questions so you get the feel for it. But the goal is to take information, turn it into an equation, and once you have the equation, use it to answer questions. So here's example 1. All of these examples should seem very familiar from grade 11. So here's example 1. The tides at Lake Lovemath changed the depth of the water in the harbor. Measurements were taken one day, and it was determined that the tides have a high point of approximately 10 meters at 2 p.m. and a low point of approximately 1 meter at 8 p.m. Determine the equation that models the depth of the water d at t over time t in hours. Assume that t equals 0 occurs at midnight. So they've already defined your variables here. I always get some student here who messes up and they use y's and x's where they've defined this, and I will take off 4 marks because I want the function to be in terms of d at t and t, because it's been defined for you, so please use the variables defined. So the key here is a trigonometric model. The nice thing about trigonometric models, you can even just say it has to be sinusoidal. The tide is never going to have a tangent, right? The tide's not going to infinity, okay? Right? And then it goes to negative infinity. That doesn't make sense, right? So we're talking, anytime we're modeling real life, we're talking about figuring out which model, whether it be sine or cosine, is going to be used as our parent to model, right? So in this case, that's just the parent, but we need to figure out what transformations need to occur in order to model this specific situation. So, moral of the story, we need to take this information and find A, K, D, and C. If we find those 4 things, we have a model that we can then use. From what we've learned, I would say remember back to our lesson on transformations. You guys remember that the last example we did was a chart. There was like a table of values, and we had to come up with the equation based on that table. If you also recall, when we did that lesson, we figured out 4 different ways you could have used that same data and come up with 4 different equations. That's the idea here. There's not one equation that's always right, but usually there's one equation that's the easiest. And we're going to go for easy now. Okay, pick the most applicable one. Okay, so here's the nice thing. A, K, and C will always be the same no matter what. This information only gives you one possible A, one possible K, one possible C. We just have to find it. Do you remember that A and C? If you go back to your notes again from that 6.4, A can be found if you know what pieces of information in a problem like this. A and C. Let's focus on A and C. A is your amplitude, C is your equation of sinusoidal axis or your vertical stretch compression, and your vertical translation. Those pieces of information are found if you know what in the problem. The max and the min. Okay? So let's start by finding the possible values of A. I'm going to put the bars because I'm not 100% sure if A will be negative or positive yet. And do you remember which operation do we need to do with max and min for the value of the absolute value of A?
Plus?
No. It's the minus. Okay? For amplitude, for A, you want minus. Okay? You want the distance. Remember, distance is subtracting. Final minus initial gives you distance. You want to take the full distance between max and min and then divide by 2. That's half the distance. That's your amplitude. Okay? So max minus min minus over 2. In the question, what is the maximum depth?
10.
There's the max. What's the minimum depth?
1.
That's your min. So A and C are findable by just plugging into this formula. So 10 minus 1 all over 2.
4.5.
Yep. There it is. I have that magnitude of A is found. Let's find C. C is where the sinusoidal axis, which always lies in the middle of your function. If I want to find the middle of something, I take the average, and so instead of max minus min, to take an average, I do max plus min. Okay. So now it's 10 plus 1 over 2, which is 11 over 2, or 5.5. Okay. 50% done finding things. Okay. I usually give 4 marks to one of these. So even if you get the rest wrong, you're going to get 2 out of 4 because you found 2 of the key values. Okay, let's go for 3 out of 4. So the next thing that's always going to be the same no matter what is going to be K. K depends on the what. You can remember right? K is your horizontal stretch compression. It's how often cycles occur, right? It's going to be related to that, and therefore it's related to your period. Is the period given here? Let's think about this. It doesn't hurt to maybe draw a little mini sketch of what you know. I know that at 2 p.m., well, if time is 0, what's 2 p.m. is really what time after midnight? How many hours after midnight is 2 p.m.? 14, right? So 14, what do I know is happening at 14? I know that I have my max tide of 10. Agreed?
Yes.
And what happens at 8? So when does 8 occur? 8 occurs
20.
at 20, right? 6 hours later. Okay, 2 p.m. to 8 p.m., 6 hours. And I know that I'm at my min depth of 1. I went from max to min. Please don't just go, connect the dots, right? That's horrible. That's not what the sinusoidal graph would do. What should happen midway between 14 and 20? There should be a middle point. That would be where, it's on the board here, where that middle would be. Yep.
Go 5.
The 5.5, the middle. And when you add that point, now can you kind of see this is really what's happening? That's the piece of information you can kind of extrapolate from just knowing those 2 pieces of information. Those 2 pieces of information are 2 points. So because we know it's sinusoidal, I know that in the middle I have this middle point. So when I look at that, how much of a cycle did I just draw?
1.
A full cycle? Half a cycle, right? It's not this repeated, right? That's not right. It's half a cycle. So what do we know is that between 14 and 20, or on the 6-hour interval, is half a cycle. So how long is the cycle? 12 hours. So you don't need the picture to do this, but now hopefully you recognize that to get the period, it's going to be the 8 p.m. or maybe I'll go to 20. Doesn't really matter. 20 minus 14, but then I have to times it by 2. 6 times 2 is 12. It's a 12-hour cycle. Hello.
Sorry to interrupt. Do you have a key to the closet?
Yeah. So 12-hour interval is our period, but that's not K. So how do I find K if I know the period? Was there a formula we learned? To get K, 2 pi over the period. And so 2 pi over 12 is pi over 6. So this is a bit strange, but K has pi in it. This is why, and I'm going to write the equation, I'll go into a little bit deeper of why we shouldn't be shocked about that. But that is correct. Everything's great, good to go now. So I have 3 of the 4 pieces of information I need. Okay? No matter what you do from this point on, every single one of you should find those 3 numbers. The 4th number will depend on your personal choice for this next bit, because the last thing that's left is D. D is your horizontal translation. Why can't I just say it's going to be the same for everyone? Because it all depends on your parent choice. And if you remember, thank you. When you remember what we did last week, we have technically 4 choices. Positive cosine x, negative cosine x. Positive sine x, negative sine x. Let's forget about the sine x's for word problems. They're just annoying. Like, okay, there might be the one odd case that would be a perfect match, but 95% of the time, picking cosine or negative cosine is going to be your better bet. So let's think about cosine. Let's make it the easiest as possible. Let's pick cosine. What that means is as soon as I choose my parent to be cosine, in my brain I should be going, okay, cosine starts at a max. I need to shift to the first max I know that where it's located. Any location of a max, that's where I need to shift to. That's what my D value needs to be. So to finish this off, so the parent choice, y equals cos x. Therefore, D will equal, where is the first location of a max? Or where is a known location of a max? 14. Right? 2 p.m. is 14 hours after midnight. Okay? So there's my 4 numbers. Let's put it all together. Using those variables. Don't go y and x on me. Okay? It's D at t. Okay? D at t equals the A value. I don't need a negative because my parent didn't have a negative. Okay? 4.5 cosine. Open square bracket. Now I need K, pi over 6. Open round bracket. What variable am I writing?
T.
T. Minus the D value, 14, close, plus 5.5.
Would it matter if you put 2?
It would work. But then what you would maybe have to justify is like also at 2 a.m. or something because of the 12-hour pattern. If you did that, that would be acceptable. Did everyone get that 2 a.m.? Because the 12-hour cycle, 2 a.m. and 2 p.m. will have the same tide height. Okay, your tide depth. So that would be true. But that's the key. That if the period is 12, then you could put 14 here or 2 here, and those essentially does the same thing. So the one thing here that's a little freaky is the fact that K has pi in it. But this is why that's necessary. A trig function, what's the only input you are technically allowed to put into a trig function? Like on your calculator, what mode did we say you have to be in for you to calculate with trig? Radian mode. Last year you had to be in degree mode. And it's because when you type in cosine and you put a number in, only numbers you're allowed to put into a trig function are angles. Is t an angle?
No.
T is a time in hours. What does pi over 6 do to your time? It converts it into an angle that matches. Does that make sense? I input a time. The minus 14 puts it into the right spot to be at a max. Then I times it by pi over 6, so now it's on the correct scale for a period of regular cosine. Is this making sense, guys? I input that into cosine, I get my output. The output will be between -1 and 1, because those are the only outputs I'm allowed for cosine. And then timesing by 4.5 and adding 5.5 will then adjust it back to be a correct temperature. Or, sorry, depth, in this case, depth. So that's all the work that goes into this model. all you really need to worry about is doing those 4 steps, right? You find your A, you find your C, you find your K, you choose your parent to then find your D, and then put it all together in your equation. Finish. There's the equation. Any questions? Literally for these questions, this is like step 1, find the model. Step 2, use the model. That's going to be the typical question on your test. Okay, let's do the step 2. Determine the depth of the water at these times. 3:15 a.m., 5:45 p.m. So if I want to use the model with 3:15 a.m., am I putting 3.15? Is that right? Right? This is clock time. I need to turn it into time after midnight. Yep. Yep. 3:15 is what? How many hours after midnight is 3:15 a.m.? 3 hours and?
15 minutes.
How much of an hour is 15 minutes? Quarter of an hour. So 3.25 hours after midnight. You have to turn the minutes into a fraction out of 60. If that makes sense, 15 out of 60, a quarter. So there's my number. So I'm going to do D at 3.25 equals 4.5 cosine square bracket pi over 6 round bracket 3.25 minus 14 plus 5.5. So I want to see the substitution step. I don't need to see a lot of, I just now want to see the answer. So you can let your calculator do the work for you here. Please note, depending on how good your calculator is, you go to bracket bonanza. As long as you keep brackets around everything here, you should be fine. If you don't have the greatest calculator, you may want to work from the inside out. Does that make sense? So find the angle, go cos angle equals, then times 4.5, and then add 5.5. So I'm going to go all at once. 4.5 cosine, open bracket. Now, I'm going to be super careful. My calculator might be able to handle this, but I'm actually going to put pi over 6 in its own little set of brackets to keep it as a single number. So I'm going to go, so I've opened a bracket after cosine. I'm going to open another bracket and go pi over 6 close bracket. Then I'm going to open another bracket and put 3.25 minus 14. I'm closing the bracket with just that part. Then I have to close the full outer bracket and then add 5.5. And if you did this correctly, hopefully you matched me as getting the number 9.070. And honestly, it's for your benefit to try and make sure you can do it on your calculator. Make sure you're in radian mode.
Oh.
If people are taking physics, be careful.
Yeah. I have physics for this.
Okay? And then 5:45 would be, so that's in the afternoon, so 12 hours, so degree 17. And then 45 minutes would be 0.75. And just to practice, repeat, so D at 17.75 equals 4.5 cosine pi over 6, 17.75 minus 14 plus 5.5. So again, make sure you can do it on your calculator. 4.5 cosine open bracket pi over 6 close bracket 17.75 minus 14 close plus 5.5 equals 3.778 meters. Guess who's losing a mark if you forget your units? You! Don't forget your units. Yeah, you guys love this, right?
Yeah.
Guess what else? Approximate. You want the stars to add up. So be careful.
So
Okay.
do you have to keep it to 3 then?
Keep it to 3. Whenever not in doubt, if you don't get a different instruction, round to 3. Any questions on that one? Moving along. Data. So here's some table information. It says, the following table shows the average monthly means of the daily 24-hour temperature in Hamilton, Ontario. Each month's average temperature is represented by the day in the middle of the month. State the equation of the sinusoidal function that models the situation. estimate the average daily temperature in Hamilton on the 200th day of the year. This is pretty much the same question you just did, except different context, and instead of information just given, the max temp occurs on this day, the min temp occurs on that day, it's given to you as a table instead. So instead of me telling you when the max temp and min temp are, guess what, guys? You have to find it yourself. So, let's see, can we find the max temp? Whew, when is it going to be the warmest, guys?
December.
Okay. Maybe
July.
July seems reasonable, right? July, do we agree that's the max temp? And where's the min temp?
It's December.
Mm,
Oh, March?
Yeah.
No, it's December.
Yeah.
January. Oh.
Okay. And I guess you might be saying, I think being February's colder is not very accurate. Well, it's Hamilton, so we're just gonna go with it. Okay. All right. So the idea here is all the information's there. You've identified the max and min. Do you have any? Can we all get 2 out of 4 right now?
Yeah.
Because we can find our A and our C, right? Max. I'm going to leave you the space, so I think it's great if you write the formula and then put the number in, just so then, it's just to keep confirming to yourself that you're doing it correctly. It's also a chance that in case, like right now you're about to put a double negative, you might forget if you don't have the formula there. I'm just suggesting. Okay, so 21.9 minus negative 4.8 over 2. 21.9 minus negative 4.8 divided by 2.
13.35.
Very good. 13.35. Because you're dividing by 2, you guys get this will always be a nice terminating decimal. Even if it starts with decimals, it won't be a non-repeating stuff. Okay? C, max plus min over 2, which will be 21.9 plus negative 4.8 over 2, which will be 21.9 plus negative 4.8 divided by 2, 8.55. So there's 2 of my 4 pieces of information. Let's find the third predictable piece of information. So before we're going to find K. Let's state the period first. So from this, there's 2 acceptable ways you can justify the period here. We can use the strategy we just used for the tide question. Do we know when the max and min occurred? So could you find how many days have passed between the max and the min?
Yeah.
But then is that the period?
No.
That's half a period. You'd have to then times by 2. Yes. So if you do 197 minus 15 and then times by 2, you get 182 times 2, which is 364. I will accept this because based on the data, but some of you might have just gone, well, this is an annual pattern, and what might you have picked? 365. If you want to justify period is 365, bracket 1 year, and you justify that. If you use 364 or 365, you're going to get approximately the same answer. It's a model that's approximating it. I'll take either one of those. Okay? Does that make sense, everybody? Okay? So I'm going to stick with the 364. Okay? So how do I find K now that I have my period? K is 2 pi over period. 2 pi over 364 is pi over 182. So there's my K. Okay, so last but not least, now it's finally choose your own adventure time. So what parent do you want to choose? Shall we stick with our plan, or do you want to go for min? What do you think?
Coast.
Okay, positive coast?
Yeah.
Okay, totally fine. As soon as you pick parent positive coast, then what's D? You need to find the location of a what? Max. If you chose negative coast, then you're picking location of a min. It doesn't matter which one you pick, it's fine. Okay? So which one we're going to pick? We're going to pick max. So shift to the max. Where is the max occur at?
197.
Right, you pick the day, right? You're picking the day that occurs. Now, the one thing in this question that didn't show up that you might want because it's not in the problem is we may need to define what variables we're going to use. Okay? It's not in the chart, it's not in the information. I'll be nice to you on the test, I'll probably already define the variables for you, but then use them. Okay? So if we want to create the model, what variable do you want to use for day of year? X or D for day, what do you think? This D doesn't mean, this is just in the model, right? It's not necessarily day of year. You guys want to let D be for day?
Please pay attention to the following announcement. Attention all muscles. If you are interested in non-reading magical things, come and join the Order of the Red Hawk. There will be a brief information meeting in the library after school today. All are welcome. Hope to see you there. Continuing next week throughout November, the library will be closed during period 3A and 3B. It will be closed during period 3C. The library club will meet right after school this Wednesday, November 14th. Learn how to manage your time and get things done. Join us for a study skills seminar, productivity hack, on Wednesday, November 14th after school in room 332. See Mike Redan and Miss Wilkins for more information. Peer Ministry. There will be a meeting tomorrow in the chapel at 2:45. We will be discussing a very controversial topic. Come and see. All are welcome. Thank you for listening to the end of the school day announcements, and I hope you have a great rest of your day.
Okay. So T at D equals, do I have all the pieces of the puzzle here, guys? Put it all together. We picked positive cosine, so I picked positive value for A, 13.35. Cosine, open square bracket. Now I need K, pi over 182. Open round bracket. Now I need the variable I just defined, D, minus, what comes next? 197, close, and then plus 8.55. There it is. There's the model that represents temperature every day of the year in Hamilton. Okay, and so now could you use it to find the temperature on the 200th day of the year? .35 cosine, open bracket, pi over 182, close bracket, 200 minus 197, close bracket, plus 8.55, 21.882 degrees Celsius. Does that actually make complete sense when you think about it? If the 197th day was this temperature, it makes sense it's slightly less. But we're still really close to that max temp location. Okay? Make sense, everybody? Okay? So that's from data, how you would do a question like this. One last example. Ferris wheel. Okay? A Ferris wheel has a radius of 20 meters, and the axis of the wheel is 24 meters above the ground. Axis of wheel could just as easily have been axle of wheel, just so I probably meant to write axle, but anyway. Axle of wheel, axis of the wheel is 24 meters above the ground. The wheel does 5 complete revolutions in 3 minutes. So this is again, all the info is in that first sentence, those first 2 sentences. Determine the sinusoidal function that models the height of a passenger riding the Ferris wheel, h at t, over time t in seconds. Assume the passenger is at the bottom of the wheel at t equals 0. Okay, so shall we draw a picture of the Ferris wheel just to get a visual of this? Sure. So Ferris wheel. Is this Ferris wheel just rolling along on the ground, or what's happening? We know we know it has a radius of 20. So I can put radius 20 this way. But just as easily, this might help us. You guys get that there's radii vertically as well. Okay? And I know that the axis of the wheel is 24 meters above the ground. Well, wait a second, what does that mean? The axis of the wheel is 24 meters above the ground. Just think of when you've traveled, and how many of you have ridden a Ferris wheel before? Okay, let me try that again. How many of you have ridden a Ferris wheel?
Oh.
Come on, even like baby ones, are like, I don't know, like at Woodbine, isn't there one that goes around, and like Fantasyland or whatever that place is? Anyway. Okay. So the idea here is usually to get on a Ferris wheel, it's not just like Ferris wheel and just walk right into the bottom of the wheel. You usually have to climb up a little bit to get onto a platform where you get on the wheel. I don't think it's very dangerous if this is the ground and your like feet are like hitting the ground here, or the wheels scraping the ground every time it's coming by, right? That's not good. So the idea here is it's on a platform. Even though my pot now it looks like a crystal ball or something, but you get the idea, okay? So there's my Ferris wheel, okay? The middle of it lies 24 meters above the ground. The radius is 20. Now, let's go. I want to go about this like we did the last two. Can I, just based on the information there, do I know what the max and min height of a rider on the wheel is going to be? If I'm riding the wheel, we agree that the two red points I just plotted will be the lowest a rider on the wheel will be and the highest a rider will be. So, do I know the max height and min height of this wheel? The max height is 44 meters. Everyone good with 44? It has to be the diameter of the wheel plus the 4 for the platform. 44. The min height, subtract the diameter because now you're at the bottom of the wheel, but you still are above the ground by 4 meters. Okay. So I'm going to go about this using the same rules we just did twice, where I'm going to find my A and my C using my rule with max minus min over 2, max plus min over 2. But hopefully you recognize something that maybe we don't have to do this for Ferris wheel questions. Okay, you might notice something. Let's see what you notice. So magnitude A equals max minus min over 2. So that's 44 minus 4 over 2. 40 over 2 is 20. Wait a second. 20, didn't we see that number?
Yeah.
What was 20? It was the?
Radius.
Does it make sense that the radius of the wheel will match the amplitude?
Yes.
Because if I'm on this wheel, right, isn't my height doing like this? Essentially, right? Like I'm transplanting, obviously over time, right? But the idea is that the max and the min is going to be the same as the radius. Like, or the distance to the max, the distance to the min will be the same as the radius of the wheel. Does that make sense, everyone? So, for a wheel question, if I tell you the radius, you don't have to show me max minus min over 2. You can just say absolute value of A is 20, bracket, radius of wheel. If you tell me radius of wheel, I know that you knew that that's a rule, that the radius of the wheel is the same as the amplitude. Okay? So maybe you kind of see where we're going with this. What do you think C, how we're going to find C? It will be max plus min over 2. Or 44 plus 4 over 2. 48 over 2 is... Ooh, we knew 24 too, didn't we? What was 24? Height of the axle. Height of axle. Again, remember, C is the equation of the sinusoidal axis. So does it make sense that the axle or the line that you rotate around will also be where the middle of the wheel is? So if you know that, again, you could just go C equals 24, height of axle above ground. You can just go right to those two numbers if you recognize that from a wheel question. Okay, now let's do K. So before I can do K, I need the period. They didn't just tell me the period, but they did give me some information. They told me that the wheel does 5 complete revolutions in 3 minutes. This is where a lot of students mess up, because I'm not telling you, what is period again? Period is how long it takes for one cycle to occur. In this case, for one revolution to occur. So should I do 5 divided by 3 or 3 divided by 5? Does 5 revolutions in 3 minutes. If I do 5 divided by 3, that's going to give me 5 revolutions over 3 minutes. It'll get revolutions per minute. Is that how the length of one revolution? If you do 3 divided by 5, that's minutes per revolution. Is that what we want? 3 divided by 5 will be the time it takes per revolution. That's what we want, time for one revolution. So to get the period, it's going to be time, 3 minutes, over 5 revolutions. That's 0.6 minutes per revolution. Isn't that the definition of period, guys? How much time it takes for one revolution, one cycle? Whee! Okay. So, okay, now, I missed this in period 1 and we corrected it later. What, did you notice something in the instructions about the model we're going to use that we should maybe pay attention to right now? True, but it's more about the units. Where T is in, right now, what would, if I kept going now, what would T be in? So can we do a quick adjustment here? That 0.6 minutes is how many seconds per revolution? Right? 0.6 times 60 would be 36 seconds per revolution. So if you guys get the 36 seconds, that's the length of one period. You go around once every 36 seconds. That's not that fast. 36 seconds?
So you're going around like twin.
Okay. Well, we're a little on the dangerous side. Okay. So, well, if you're on like, maybe not a Ferris wheel, but you know, there's like some of those like, you know, spin rides go pretty fast.
Yeah. So like, that's like keeping you there. There's like
So like, I don't know. Let's not get into minutes. We have 4 minutes left. So remember, guys, I'm going to keep going because I want to finish this question. If you have to leave, leave. But hopefully I'll be done in like 5 minutes after this. Okay? So the idea is 36 seconds. I know my period. Can I then find K? 2 pi over period. So K is pi over 18. Okay, so I have all the pieces. Well, actually I have 3 of the 4 pieces. What's the last thing I need to do?
pick a parent.
Pick a parent. This time, there's a super smart choice for parent. And it's all about the last sentence. Read that last sentence, guys. Assume the passer's at the bottom of the wheel at time 0. Bottom of wheel?
Negative sign.
Bottom of wheel is 4 meters above the ground. If I pick negative coast, why would that be a smart choice to choose negative coast? How far do I have to shift to a min if I choose negative coast? I don't have to shift because it's already happening at time 0. The min, I get on the ride at time 0, I'm at the min, and so I can just use it and I can say no, D is 0. So negative cosec, therefore D equals 0. Put it all together. Formula H at T equals, so I just got to remember something. If I put a negative here, guess what I write in front of A? I need to write negative 20 cosine. I don't need the double layer of brackets because D is 0, so I just need KT. So pi over 18 times T. And then plus FT4. Ta-da. So there's my model for this riding the height of overtime for riding this Ferris wheel. Part 2. Part B says, make a sketch for 3 revolutions. I will make you do this once on your test. I'm not saying make a graph, I'm saying make a sketch. You have everything you need to make your sketch here. This is all I want to see. I want to see along the bottom, if I want 3 cycles, you're going to start with 3 ticks. If one, what did we say one revolution takes? It takes
36 seconds.
So what should I label the first tick?
36.
And the next tick? You can all, I think you can all add. 72. And then the next tick? 108. Okay. Yes, you're right. Okay. In terms of your vertical axis, so again, this is H at T and T. Well, what was the min and the max? This is where the min and the max would be helpful. The lowest a person is off the ground is,
4.
and the highest they're off the ground is.
44.
And maybe to help us out, where is the middle?
21.
Okay. So, based on the information, at time 0, person at the lowest part of the wheel. After 36 seconds, where's the person? At the lowest point on the wheel. After 72 seconds, where's this person? At the lowest part of the wheel. After 108 seconds, where's this person? Lowest point on the wheel. Okay, it's okay. Just watch the video to finish, please. Okay, so now, that doesn't look very sinusoidal. What should I do to help me figure this out? Where will the maxes be? Again, you should know the shape now at the back of your hand. Middle will be max, right? Sorry, Matt. Poor Max, his name's gonna, I think he's the only student that will hear his name like hundreds of times during the school year in math class. But anyway. All right. And then, this always happens. Again, do not be the student that does this. Woo! Look at my graph. Beautiful.
But,
Horrible.
Miss, if we're doing like saying you still have to connect the dots.
Well, that's the thing. How do you connect the dots? The middle's helpful. I'm okay if you want to just draw yourself a guideline here, i.e. the sinusoidal axis. It's not an asymptote, it's just a guideline. Why would that be helpful? Because if the min is here and the max is here, what happens in the middle of the middle? Normally, if it was apparent, this would be where the zeros would be, right? Is this going to help us? You guys get that what I've just done is I've created all of the max, mins, and middles and like zeros for the shape. Can you now happy sad this up? Happy sad, happy sad, happy sad, happy. Oh, look at that, so pretty. It's not a zigzag, right? You don't want to be on the Ferris wheel that's a zigzag. Like, okay. So that would be the sketch. Everyone happy that I want labeled? I at least want the labels of the ends of the cycles, and I want the vertical scale labeled like that. Last but not least, find the height of the passer after 1 minute, 5 seconds. You have your model. You just have to figure out 1 minute and 5 seconds. The model works with seconds, so what are you going to input into the model?
65.
Beautiful. H at 65 equals negative 20 cosine pi over, I want to say 18 times 65 plus 24. And we get negative 20 cosine, open bracket, pi over 18 times 65 plus 24. 17.160 I got. Okay? I appreciate you staying the extra 5 minutes, guys. We are officially done the unit. Remember, bring your textbook tomorrow. You'll get a work period to kind of work on. Finish up any outstanding work from the unit and start the review. Thank you for listening.